Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hello friends, today we are starting another sum of AFD, SFD and BMD, question number 5. Let's see. Here is a question number 5. Draw AFD, SFD and BMD. See, in this question, what is this given? See, this is internal hinge. Please keep this in mind. This is nothing but internal hinge. And this is UDL of 20 kN per meter, and this point load of in eccentricity is 10 kN. Okay. Now A, B, C and D, this will 4 meter, this will also 4 meter, and this is also 4 meter. Now see, in this, see this both are hinge. This both are hinge, not a roller. Okay, so that's why it is indeterminate structure. To determine this structure, this internal hinge provide over here. Now our first step is to find the reaction. Let's see. Solution. Solution, support reaction, calculation. Okay, now what is come first over here? Now see, this is your question. Okay, this is your question given over here. See, now what we have to do, we have to find this one. This is VA and this is HA. Sorry, this is VD. Okay, since there is no horizontal force in the given frame, that's why this will come 0 and this is also come 0 without solving. Okay, now we have to find VA and VB. To find VA, what we have to do, taking moment at A normally. Taking moment at A equal to 0, clockwise positive. Okay, now what will we come? See, first see, since UDL is coming, since we are taking moment over here, we have to put our rod over here and apply 20 kN from upward. This will go clockwise direction. So 20 into 4 into 4 by 2. 20 into 4, this is load, into 4 by 2, this is perpendicular distance. Okay, 20 into 4 into 4 by 2, this will come positive. Now this is also going clockwise direction, so 10 into this distance, this will be 1 meter. So this will come 10 into this distance is 5 meter. So plus 10 into 5. After that, after this, what is remaining? This VD is remaining. VD into this distance. VD, sorry, this is going this direction, this is anti-clockwise, so VD into this distance will be 4. So VD into 4 minus VD into 4 is equal to 0. While solving this, you get the value of VD is equal to 52.5 kilonewton. Okay, this is your VD value. Now we got the value of VD 52.5 kilonewton. Now let's see. To find VA, simply apply summation Fy. Summation Fy equal to 0, upward, positive. See, this is going up, 20 is positive, 20 into 4 negative, plus 52.5. See, this is VA minus 20 into 4 plus 52.5 is equal to 0. While solving this, you get the value of VA will be 37.5 kilonewton. Okay, now we have done with this part. We have find the reactions, 37.5 kilonewton. Now we have done with this part, VA and VD. Since after that we have to apply summation Fx is equal to 0. This is positive. There is no horizontal load. Because there is no horizontal load, so HA is equal to HB HD is equal to 0. Directly you can solve in this sum. Directly you have to write over here also. Directly you have to say 0 because there is no horizontal load coming in the frame. After that, we have done with these two parts. What is our next part? In next part, what will we do? We are doing to separate all the members, all the members and draw that AFD, SFD and BMD, which is given in the question. Draw AFD, SFD and BMD. Now let's see, consider first part AB. Now our first part will be consider AB first. Okay, now we are considering part AB first. Now draw the FBD of AB part. Now just see, this is given loading right in this same pen, 37.5. this is going 37.5 kilonewton. Now see, this will be 0 over here, this will 0. Now see a part A, see a joint A and balance the joint B. No need to see over here, UDL is given, the point load is given. Simply ignore this all part. Simply you have to see this AB part only. Now you have to see the A and balance the B part while seeing A. Okay, now see how will you balance. See, 37.5 coming from this to the upward. So to balance this, we have to downward this reaction, 37.5. now this is will 0, this will also 0. After that, what we have to do, after that we have to extend the part and draw AFD, SFD and BMD. Okay, now our first file will be AFD. See, first we have to draw the beam first. This is your A, this is B. Since this is compression, so compression means minus sign. See, this is compression means minus. Means what you have to do, what I am saying in the previous sums also, minus means you have to draw the diagram inside the frame as you are standing inside the frame. Okay, first we have to take, see, AB part, what is the inside part? Inside part will be this side, so this will come like this. This one is 37.5, this is also 37.5. now I join this two, this is minus sign. We have done with this AFD part. Now since there is no vertical force, see this, there is no horizontal force, that's why shear force will be 0. See, there is no load, 0 0, that's why it will come 0. And for bending moment, always see the original diagram. Okay, now see the original diagram over here. What is bending moment A? Will be 0. What is bending moment at B? Either you can take this part or you can take this whole part. We are taking this whole part, there is no vertical, there is no horizontal force, that's why bending moment at B will also be 0. Okay, that's why this part must also come with 0. This is your SFD, this is your BMD. Okay, now we have done with the first part, A and B. Now see students, we have done with AB part. Now let's see how to solve B and C. First, draw the free body diagram. Now consider part B, C and E. First draw the FBD of that part. Now see, as you know students, this will go 37.5 go downward to balance point B at point BCE, means that you have to take upward 37.5. or else you can simply this 37 point put it over here, and this 52.5 put it over here directly. This is also possible. This case is also possible. Okay, this is B, C, this is E. After that, what will we do? First we have to extend this all part. Now see, we have extended this all part. Now draw the AFD, SFD and BMD. So okay, since there is here no load, this is will come 0. This is also at 0. This, since there is no load over here, so AFD will be 0. Now draw the AFD first. Since, as you all know, no axial force in the beam BCE, that's for AFD will be 0. AFD. Okay, after that what we have to find? We have to find SFD. To find SFD, draw over here. Okay, this is your B part, this is your E part, and this is your C part. Okay, now what we have to do? Shear force calculation. If you want, you can calculate over here only, or you can directly draw the diagram. I'm just explaining you once again. This first one is shear force calculation. This will come positive. Now see what has come. Shear force, see, shear force B at left means you are taking section over here. This marker is nothing but this dot line. Okay friends, this marker is nothing but this dot line. We are seeing marker over here, and we are seeing from left part. Okay, in left part there is no load, so that's why shear force B at left will be 0. Now put it, mark it just right. Shear force B at right means just right of the section, and you are seeing only this part. What the value will come? This 37.5 is only coming. See, don't take this distance because this is negligible. Just left and just right is there, so no use of UDL over here. See, you are taking section, this dot line, this marker, this dot line consider as a marker. We are taking marker over here and seeing section over this side. Okay, so this side, what you have seen, this side, see, this is saying 37.5 upward. See, section this side upward goes positive, so this will come 37.5 kilonewton. Okay, now after that, shear force C at left equal to, means you are taking section over here. In this, you have to see either this side or this side. What side will you come? We will see this side, because this is more convenient for us. In this side there have a UDL, so we have to 37.5 plus minus 20 into 4. This we have to do. We are taking this side we can see downward comes positive, so this will positive and this will negative. Okay, so it's your point of view. If you want, you can take left or we can take right. I am taking this part over here only. See, this 37.5 plus 20 minus 20 into 4. 37.5 plus minus 20 into 4, you get the value is minus 42.5 kilonewton over here. Okay, or you can take this side of the 52.5 minus 10, sorry, plus 52.5, sorry, minus 52.5 plus 10, it got minus 42.5. this side also. Okay, now shear force C at right. Now you are taking section over here and you are seeing this side downward comes positive, so this is 10 kilonewton. Now shear force E at left will be 10 kilonewton. Shear force E at right will be 0. Okay, now we have done with this part. Okay, now draw the diagram first. See, shear force A at left will be 0. We are starting from 0. 37.5 come over here something. Okay, this is 37.5. Now at C, which is minus 42.5, which is come over here, 42.5 something over here, 42.5. now see, minus 42.5. now this is 10 plus 10. See, this is plus 10 over here, plus 10 over here. This is also 10, this is also 10, this is 0. Okay, now joint all the points. Since BC part is UDL, therefore in AFD, in shear force diagram, it will come incline always. Okay, in incline, and for bending moment diagram it will come parabolic curve. Now see, this distance where the shear force is 0, where the shear force is 0, bending moment will be maximum, as you all know. So draw the bending moment diagram over here. Bending moment diagram over here. This is your SFD part. Now I'm explaining after that. Okay, now let's see how will you find the bending moment. This is your B part, this is your C part, and this is your E part. Now see, number 2 will be always write the sign convention inside of that calculation, because it's very convenient to use while solving the sums. So no need any mistakes. Now see, bending moment at B. Now for bending moment, what I am seeing, always see the original diagram. Now see the original bending moment at B. I have already find out this will be 0 because there is no load over here. Horizontal load. That's why B will be 0. Directly you have to write bending moment at B will be 0. Now what about the C? Now let's come with the C part. Bending moment at C, either you can take this side or you can take this side. Okay, now bending moment at C will be, see, for bending moment at C we are taking this side. Why we are taking this side? Because this is only one load. From this side there is two load, this one and this one. We are taking section over here and we are taking this side. So this 10 will, how will 10 will rotate? It will rotate like this. This sign conversion follow, minus. So minus 10 into 1. Bending moment at C will be minus 10 into 1 will become minus 10 kilonewton meter. Okay, now see, we have done with C part also. Now bending moment at E will be also 0. Bending moment at E will be also 0. Now where the shear force is 0, now let's see students, we have drawn bending moment at B and bending moment at E. Now we have directly, you can draw the diagram first. See, in C there is how much? This is minus 10. This will come over here. Okay, this is your 10. Now see, now bending moment is maximum over here. As you all know, this is maximum part, because where the shear force is 0, the bending moment will be maximum. Okay, now we have to find this value. How will you find this? Because why we are finding this? Because we know that where the shear force 0, maximum will be, bending moment will be maximum. If you are not solving, that's also convenient for exam. If you want, you can solve also. Now see, in E this is 0, so this is straight line. This is a straight line and this is parabolic curve. Now how will you find this point? This is a main point over here. How will you find this point? To find this point, first we have to know the distance of x. What is this distance and what is this distance? So consider this distance, as x, and this distance as 4 minus x. After that, as you all know, to find h, what we have doing, to find h, what we are doing, not h, it's x, is equal to, find x, 37.5 upon x is equal to 42.5 upon 4 minus x. See, by similar triangle, as you all know, see, this 37.5 into x, 42.5 into 4 upon 4 minus x. This is nothing but similar triangle. Okay. Now while solving this, you can solve directly in the calculator. While solving this, you get the value of x. See, x will become 1.875 meter. This is your x value. After that, what you have to do, you have to find the bending moment over here from this point. This distance, you know, this will x will be 1.875. This distance will be 1.875. This distance will be 4 minus 1.875. Okay, now what now where the bending moment, what is the, we have to find over here bending moment. See what is coming. Maximum bending moment at x is equal to m max is equal to, now see, we are taking over here or here, we are taking from this side or this side. This, how it will come, this will come 37.5 into this distance is nothing but x. What is the value of x? 1.875. see, 1.875. now what this UDL will be goes minus, because this is going this direction, minus 20 into 1.875 into 1.875 divided by 2. Okay, 20 into 1.875 into 1.875 divided by 2. Now you get the bending moment at x will be 35.156 kilonewton meter. This is your value over here, 35.156. okay, now this is your SFD, this is your BMD, and this is your AFD part. Now we have done with this member B, C and E also. Now as you remember students, where we are calculating this, because we know the value of over here, just we are calculating, as you all knows, where the shear force 0, bending moment is always maximum. For your point of convenience, for your satisfaction, always find if you know. Now see, how will you find x? By similar triangle. This remember in this, remember these things. Okay, now what is remaining? Now remaining part is, see, we have done with AB part and BCE part. Now CD part is remaining. Now draw the free body diagram of CD. Now we are consider part C and D. Now draw the free body diagram of this part. How will you draw? Okay, we know that this value will be our 52.5 kilonewton. Now see, this is also no load, this is also 0. Here also it come 0. This will come over 0 over here. And now see, now just extend the part first. Now see, you balance this 52.5, you have to apply the load over here also. This is also coming 52.5. okay, now this is 0, that's why here is also it comes 0 directly, you can write. Okay, now draw the AFD part first. In AFD part, as you all know, in AFD part, this is also going compression, so minus sign. This is also compression, means minus sign. Okay, now please keep remember in these things, minus means we have to draw inside the frame. In part CD, what is the inside the frame? We have to draw in this way. Okay, in part AB we can draw like this, in this side from left to right, but in CD part we have to right to left. Okay, so please, as you are standing in the inside the frame, please remember these things. You are standing inside the frame. Negative sign means compression, negative sign means you have to draw the diagram inside the frame. Okay, now CD part inside the frame is from right to left. Okay, now you have to draw, this is your C, this is your D, C, this is D. Inside the frame will be over here. Okay, this is your 52.5 negative. Okay, now negative means compression. Okay, now what about the shear force? Is the horizontal forces are not over here, so shear force will be 0. Now what about the bending moment diagram? Just draw the bending moment diagram over here. See, as you calculated bending moment at C in previous sum and previous member, see at bending moment at C, no need to solve after also, we have no need to solve after also in bending moment at C, because I am always explaining you that in bending moment diagram we are seeing always the original diagram given in the question. So already we are finding the bending moment at C, directly put it the value over there. Okay, now bending moment at C will be minus 10 kilonewton meter. Direct put over here. Minus means inside the frame. Please remember these things also. Always minus means inside the frame from right to left. Inside the frame will be minus 10 will be come over here. Okay. Now bending moment at D will be 0. So join this like this. This is minus sign. This is your bending moment diagram. Okay. Now see, we are done with all three parts. See, we are done with AB part and BCE part and CD part. Then this is your final answer. I hope you will understand my videos. Thanks for watching.